Hello everyone, I am Sharafina, Department of Chemistry from E-Content Development Center, Majlis Arts and Science College, Puramannur. Today, I wish to discuss about the topic quantum mechanics. First of all, we are looking what is quantum mechanics and the differences between quantum mechanics and classical mechanics and the role of quantum mechanics in chemistry and the failure of classical mechanics. By the end of the class, you will get a brief introduction of quantum mechanics. What is quantum mechanics? Quantum mechanics is the science of very small particles. Quantum mechanics explains the behavior of matter and interaction with energy on the scale of atomic and subatomic particles. By contrast, classical physics also explain matter and energy on a scale familiar to human experience, including the behavior of astronomical bodies such as moon. The classical physics also used in our modern science and technologies. However, towards the 19th century, scientists have discovered that both in the large and small worlds could not be explained by the classical physics. Then we are going to the limitation of classical physics and the great development of quantum theory, and we replaced it in the early decades of 20th century. Quantum mechanics is the science of microscopic matter such as electrons, nuclei in atom and molecules. It gives the law of motion of microscopic objects. Quantum mechanics is the greatest intellectual development of 20th century. Quantum mechanics is the science which takes both the particle and wave character of matter into consideration. Quantum mechanics is made up of two words, quantum plus mechanics. Quantum is a Latin word which means amount. Mechanics is the science of motion of the body. The next topic is role of quantum mechanics in chemistry. Quantum mechanics has found application in all the fields of science, chemistry, physics and biology and other integrated fields. Quantum mechanics explains theoretically the SBR in chemical entities. What is SBR? S is the structure, B is the bonding and R is the reactivity. The influence of quantum chemistry is evident in all the branches of chemistry that are in physical chemistry, organic chemistry, analytical chemistry and so on. Physical chemistry utilizes the quantum mechanics to calculate the properties of thermodynamics, to investigate the molecular properties and so on. Organic chemistry utilizes the quantum mechanics to estimate the relative stabilities of molecule, to calculate the properties of reaction intermediates and to analyze NMR spectra. Analytical chemistry utilizes for spectroscopic methods. All spectra are understood by the understanding of the basics of quantum mechanics. Inorganic chemistry utilizes quantum mechanics for the ligand field theory, which is an approximate quantum mechanical method, and the entire atomic structure comes from quantum mechanics, which is orbital, shape of orbital, bonding and etc. Biochemistry also utilizes quantum mechanics for the biological molecules, enzyme substrate binding and etc. In all, one can say that quantum mechanics explained the SBR of chemistry, taking into account the role and behavior of electrons. Indeed, quantum mechanics has had great success in providing the general theoretical framework for chemistry. Next, we are discussing the failure of classical mechanics. According to classical mechanics, light is a wave, an electromagnetic radiation with a certain amplitude and frequency. Amplitude is related to intensity. But in quantum mechanics, light have dual character, both particle and wave nature. According to classical mechanics, the position and momentum of a system can be determined simultaneously and the energy of a system varies continuously. But in quantum mechanics, Heisenberg's uncertainty principle says that the position and momentum of a system cannot be determined simultaneously, and energy is quantized. Till the 19th century, classical or Newtonian mechanics was considered to be the only right theory of science. But soon, some other experiments are observed, and that cannot be explained by the classical mechanics. This includes blackbody radiation, photoelectric effect, atomic spectra, and heat capacity of solid. I hope you understood the topic about quantum mechanics. Thank you.